All right, today we are factoring a difference of squares. So a difference of squares is just exactly what it says. We'll be factoring binomials, squares meaning perfect squares, and difference meaning subtraction. So it's a couple of questions we need to ask ourselves before we start factoring a difference of squares. We first need to ask ourselves, is there a GCF? Is there a greatest common factor? If it is, we must factor it out. Then we ask ourselves, is it a binomial? You know, a binomial has two terms. Then we ask ourselves, is there a subtraction sign? Hence the word difference. And then we ask ourselves, are both terms perfect squares? Difference of squares. So let's just have a backdrop on perfect square numbers. So we know that perfect squares, some of our perfect square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and we can keep going forth, so forth and so forth. So why is 121 a perfect square? Because the square root of 121 is 11. 11 times 11 is 121. Square root of 100 is 10. 10 times 10 is 100. Perfect square 81, square root of 81 is 9. 9 times 9 is 81. Square root of 16 is 4. 4 times 4 is 16. So all of those are perfect square numbers. Well, you know we work with variables too. So how do we know if a variable is a perfect square? So let's talk about some perfect square variables. X squared, x to the fourth, x to the sixth, x to the eighth, x to the 10th, x to the 12th. What do you notice about all of these exponents? They're even. So that's how you know if a variable is a perfect square, if it has an even exponent. The square root of x squared is x. Square root of x to the fourth is x squared. Square root of x to the sixth is x cubed. Square root of x to the eighth is x to the fourth. The square root of x to the 10th is x to the 5th, and the square root of x to the 12th is x to the 6th. So when we take the square root of a perfect square that is a variable, all we're doing is halving it. So you know, perfect square variables all have even exponents. And when you take the square root of it, you're just dividing it in half. So let's do some examples. We're going to find we're going to factor this binomial m squared minus 6 by a difference of squares. So I ask myself first, is there a GCF? Is there a number that is in common for m squared and 36? There is not. Then I ask myself, is it a binomial? Making sure that it's two terms. Yes, it is. So I ask myself, is there a subtraction sign? It is. And are both of my terms perfect squares? Is m squared a perfect square? Yes. Is 36 a perfect square? Yes. So what I'm going to do is make me two parentheses. And I'm going to factor it. I'm going to take the square root of m squared. So if I have two m's and I take the square root of it, remember, I just halving my exponent. So half of 2 is 1. So each one of my parentheses gets an m. And then I'm going to take the square root of 36, which is 6. Well, what about my signs in the middle? One gets a plus, one gets a minus. Ms. Carter, is that my final answer? That's my final answer. We have factored out that difference of squares. So this is how you know if you're right, because we can distribute to see if we get this answer back. So m times m is m squared. M times negative 6 is negative 6m. Positive 6 times m is positive 6m. And positive 6 times negative 6 is a negative 36. If I combine my like terms in the middle, these cancel out. And I get m squared minus 36. All right, let's do an example when we have a coefficient. So I have 4a squared minus 9. Is there a greatest common factor between these two terms? There's no number that 4 and 9 have in common besides 1, but we don't really have to worry about that. So then I ask myself, is it a binomial? Yes, it has two terms. Is there a subtraction sign? Absolutely. Are both of my terms perfect squares? Well, let's take the square root of 4a squared. Well, the square root of 4 is 2. So this parentheses gets a 2, and this parentheses gets a 2. Well, what is the square root of a squared? That means it's an even exponent for my variable, so it's a perfect square, and I just half it. So half of a squared is a. And then I take the square root of 9, which is 3. And one binomial gets a plus sign, and the other binomial gets a minus sign. Well, what about 2r squared minus 98? I'm going to erase this. I ask myself, is there a greatest common factor between my two terms? Is there a number that is in common for 2 and 98? And it is. If I needed to list my factors of 2, I could, which is only 2 of them. And if I need to list my factors for 98, I could. So 1 and 98 and 2 and 49. My greatest common factor between these two numbers is 2. That means I can factor out a 2. Well, when I factor out my 2, what does that leave behind? 2r squared divided by 2 leaves r squared. And negative 98 divided by 2 leaves a positive 49. Now, do I have a binomial? Yes. Do I have a subtraction sign? Yes. Are both of my terms perfect squares? They are. So we're going to factor this binomial, but we're going to highlight this coefficient, our greatest common factor that we pulled out, because we'll need it a little later. So the square root of r squared is r. The square root of 49 is 7. One binomial gets a plus sign, one binomial gets a minus sign. Well, what about this greatest common factor of 2 that we highlighted and left out earlier? I just bring it down. All right, number 4, g squared plus 121. Is there a greatest common factor between these two terms? It's not. It is indeed a binomial. But is there a subtraction sign? No, it's a plus sign. So this is not a difference of squares. So since it's not a difference of squares, I can't factor it. Therefore, it's called prime because I can't factor it. And our very last example, w to the power 4 minus 81. Is there a greatest common factor? Absolutely not. It is indeed a binomial with a subtraction sign. Are both of my terms perfect squares? They are. Well, the square root of w to the power 4 is even, so it's a perfect square. I just have the exponent. So I get w squared and w squared. And the square root of 81 is 9. Remember, one gets a minus sign, one gets a plus sign. But if I notice, I have another difference of squares. Because it's a binomial, it has a subtraction sign, and both of my terms are perfect squares. So I need to do this again. Take the square root of w squared, and I get w. Take the square root of 9, and I get 3. And remember, one gets a plus sign and one gets a minus sign. But what about this binomial here? Since I can't factor it anymore, I just bring it down. And this is my factored binomial.